Today I wanted to talk about a general topic, and that is security and securing the beam. Open source provides us with the opportunity to be secure in quorum, our safety in numbers, if you like. We have a lot of people who are involved in something, and we have a lot of eyes on any problem that we see. And I chose some pictures as a background here of places where there are a lot of people. And I thought the pictures were great. They really describe exactly what I'm looking for, and that is that we can feel comfortable in a crowd. I envision going to one of these places where this picture was and being there alone, and not having anybody around me. And I feel that would be quite eerie to be at a large train station with no one around, or at a baseball stadium with no one around. And that feeling, I feel I can recognize that feeling, and it reminds me of the first time that I ever reached out on a mailing list to discuss a challenge I had in open source. I felt like I was entering a void. I felt like I was going to receive criticism. I was very nervous when I sent my first email to a mailing list regarding an open source problem. But very quickly was introduced to someone who said, "Hey, I can help you. I've been through that. Here's where we've documented things. Here are some other people that can help you with that." And all of a sudden I felt I'm not alone. I'm part of something. And I had a real feeling of confidence and security in moving forwards. And that's something that open source brings, not just from a personal perspective, but also in the actual security of the software itself. So if we can progress to the next slide. Some simple facts. Open source is considered by many to be the most secure software available. That hasn't always held true. There has been a lot of anti-open source marketing in the past, which lingers long in the memory of the people that have been around for a while. But in essence, open source is now really, I think, considered to be more secure than any type of proprietary code. And the reasons for that are many. But if we start with, there are a lot of developers involved, and a lot of developers who are paid by companies who are going to use the software and who want it to be secure. So we can assume that there are more good actors than bad actors. We can also assume that those good actors are each addressing different use cases, and those different use cases will test the code in different ways for security and fitfulness of purpose that wouldn't normally be done in a single user environment. We can assume also that as those companies begin testing the code and as they begin evaluating whether their products are secure, that the security of that component or that piece of software is then also verified in different contexts and different environments. So by collaborating around open source and by collaborating around the development, testing, verification, and security of the software that we're producing and sharing, we get a much more secure piece of software than, it's quite possible that a proprietary piece could be as much, but the return on investment for the time spent generally isn't there. So we can just assume in general terms that we have more secure software. And I've referenced an article here that I think it's a little old and dated now, but it's still a good article. In a world without open source software, and you can see the reference, there's a link on the page. In a world without open source software, over half of the websites on the internet would disappear. Apache Web Server is used. It's open source, and it's the most common web server. The site's still operating, wouldn't have a lot or would have no active content. Perl, JavaScript, all of the open source libraries and applications that allow this content, rich content, to be put on the internet. Electric mailing lists would stop. Majordomo, for instance, is an open source mailing list, software used quite commonly. But that really wouldn't matter because the SendMail software that most of the mail servers are built on is also open source. So we wouldn't need the list because we wouldn't send mail. Bind, as part of DNS, is open source. So you'd have to type in addresses rather than domain names. And the list goes on. Newsgroups wouldn't work. Most of our commercial software wouldn't exist without open source. We talk about proprietary software. Let's talk about Apple's proprietary software, Mac OS and iOS, or Linux derivatives. There may be a lot of proprietary software, but it's built on the back of the work of the open source communities. So I think it's quite safe and safe to understand the importance of open source software in the context of commercial endeavors, and also the fact that the open source software tends to be more secure and tends to have been far better tested than proprietary software. If we move forwards, we can talk a little bit about Beam specifically. Beam. So Erlang, Elixir, the broader Beam ecosystem is safe and secure. And it is safe and secure because of a number of reasons. One, we have a long-term, highly skilled core of maintainers. We have people that have been with this software for a long time, know it inside and out, have reviewed most of the software coming in. Well, actually, I would claim all of the software coming in has been reviewed by long-term maintainers. In other words, very, very hard for a bad actor to have been involved in this software. We can assume that it's only good actors with only good intent. And so any mistakes or issues are simply bugs and nothing malicious about them. So the fact that we have long-term skilled maintainers generally means that most of those bugs have been ironed out by now. We also have multiple languages and multiple use cases. I talked in the last slide a little bit about the different testing scenarios and testing environments. These all help going into securing Beam and making Beam more secure because of this broad ecosystem that's leveraging a common asset. That is when things get at their strongest. So I'm having trouble reading my text because I'm looking down here. There we go. Okay. We isolate from many of the common security flaws and issues that we might find simply because we're in the Beam VM. The Beam VM provides us with a safe environment at a safe location. It handles a lot of simple tasks, typical tasks, memory management and other things, which without a common function for doing so, tend to provide erroneous solutions in other languages. I don't want to point fingers and I don't want to call out specific languages, but what we can say is that because we exist in this Beam VM, we have a relatively safe environment to do our work. And the VM has been around for a long time, since the 90s. In fact, it is the second iteration. It replaces the Jam VM. So since last millennium, this VM has been around, tested, verified, and used. And not just used in random places in people's basements and computers, used in mission critical telecommunications applications, used in web scale applications. We can assume that it's pretty safe. And if we click, it's safe as in as safe as a safe. When you think about the VM, when you think about Beam itself, I think the picture of the safe there represents that to me. Could you click, Francisco? I have a text animation, which, there we go, pops up. Safe as in safe as a safe. Which actually brings me to the next thing. I'd like to introduce an actor. This gentleman is named Herbert Ellis. He's a particularly suave Sydney-sider from Australia, from the 1920s. He is a safecracker from the 1920s. So the safe that we all liked and looked at and felt comfortable around is something that this guy made a habit of opening up and getting into. It's not as safe as you like to think. Safecrackers tend to be intelligent, innovative, and persistent, or tended to be. For those that are still around, I'm sure they are as well. This type of actor these days, maybe wearing a different type of hat, maybe not wearing a tie, generally turns into a hacker. The way that these guys would make money and get wealthy, these days you do it electronically. It's a much better return on investment. But this is how it used to look. This is what a guy that broke your safety down looked like in the 1920s. Well, if he was Australian. Which leads me to think, okay, how safe is our safe? I think about safes and I think, well, they're pretty safe. You've got a key. If you don't have the key, you can't turn the lock. But these guys could figure out multiple ways of breaking into things. So things that are good to know. Applications contain on average 257 open source components. As a developer, I've written an application. I'm very happy with my application. I want to sell my application. I'm very confident in the software I've written. I'm maybe less confident in the 257 other components that I've pulled in from open source. If we click again, in the last year, there has been a 430% increase in cyber attacks targeting open source software projects, more than 4 times the year before. I mean, it's not like it's doubling, it's quadrupling. Open source, while it becomes more and more popular in the market, becomes the most common way of solving problems for software developers, also becomes much more of a target for cyber attacks. So how common a target? Well, there is a prediction that during 2020, if we click again, there will be 1.5 trillion open source component downloads occurring. So that's 1.5 trillion downloads of open source components, which may or may not be very well known by the developers using them this year. If we click again, we get another statistic which states that 11% of all components used in applications are known to have OSS vulnerabilities. So 1 in 10 components used has a known vulnerability. It's not an unknown vulnerability. This is something that we actually know about. And so it's something that guys like the Safecracker here already know exist and already know or have figured out or are figuring out how to get into them. And what does that mean for the average product? If we click again, on average, there are 38 known open source vulnerabilities in any given application that is shipped. It's a bit scary to think that. Even though you know that these things are happening, even though you know that there are security issues, it's very hard to not ship products with them. We have tools now which are helping, and the tools can tell us about the known things. But if we click again, we learn something new, and that is that next-gen, more aggressive attackers are actually implanting malware directly into open source projects. They are contributing to projects in ways that introduce new faults. And that's very hard to protect against. I mentioned that the Beam has a strong core of maintainers who have been with the project for a long time. That's not common. And so for projects that don't have a strong core of maintainers, that haven't had architects involved in it for a long time, there can be issues when patches are pushed that are malicious in nature, but people may not have noticed that. Now, on the plus side, if we click again, the most targeted software here is Node.js and Python. They're the two biggest targets, I guess. Erlang, Elixir, the Beam, not such a big target. However, if we keep clicking, there are things that we need to consider when it comes to using Beam. Where do we pull our dependencies from? Where do you pull your dependencies from? What are you pulling? Have you read the code? Do you know how the code is written? Do you know who's contributing to it? A lot of things to contemplate, given that there may be 257 different components that you didn't write in your application. And not only that, maybe I'm pretty confident in the components that I'm using. Am I using end-to-end encryption when I pull them down? Because it is also possible for a malicious action to replace midstream the software that you think you're pulling. There are companies that will pull a piece of software 5 times before they use it, just to make sure that they get the piece of software they intended. So every time they want to download a piece of software, they do it 5 times, and then they use the piece of software. But if we click again, I think we have to ask ourselves a question, and that is, do we really know what tools like Rebar, Rebar 3 and Mix are actually pulling on our behalf? Have we taken a look into the soup that is that build machinery and understood what's coming in? Have we understood how is it coming in? Is it secure to bring in? Is it securely delivered? And have we checked that all the vulnerabilities are solved? And I'm not trying to pick on anyone or anything. This is just a simple fact. We need to be vigilant about where we get our software from and how we compose it. It's a constantly moving target. And that actually brings me to the next slide, which is an interesting one. I want to talk about when you know what you're protecting against. In Australia, we have something called the Dingo Fence. It's a lot of fence. It's 5,600 kilometers of fence. It literally is a fence around the corner, the eastern corner of Australia. The intention of the fence is that it secures farmers' stock from dingoes, and it's critical to South Australian and Victorian industry where there's a lot of sheep farming. To put it in context, we all know about the Trump wall and the big fence President Trump is trying to build. That one's about 3,000 kilometers long. So it's a little over half the length of this one that we built in Australia. It's there to protect. It's to protect against a known aggressor. It's a known way of protecting. The fence is understood to work. The fence is understood to protect against this particular issue. However, if you divide the length of this fence by 10 million, so you slice it up into 10 million pieces, if 1/10,000,000th of this fence fails, dingoes can get through. It just takes 50 centimeters, that's all. And then you've got a dingo through. So if you can imagine a fence, which is, as you see, made of wood and wire, it's meant to last forever. And every 10 millionth of it that fails is essentially failure of security. Then we have a bit of a problem. So if we click again, we can sort of see one little problem that pops up occasionally. They get holes. There's a hole in the fence and a dingo can get through. Building a security solution is one thing. Any security solution that you build, as good as it may be, as purposefully constructed as it may be, it requires maintenance. And maintenance is not free, and maintenance requires attention. Maybe the dingoes get longer legs and jump higher. Who knows? Maybe they start digging. There could be different things that go wrong with your security solution. The two things that are quite clear here, you can get holes in this fence. And you look at it, if you look at the picture of it, the wood, it's getting old. The metal is rusting. So the government that built this now has a challenge. They have to find $25 million or something to continue to maintain and update this fence, which will have to be done as long as the fence exists. There's no way around that. So it is a common and constant cost associated with any security solution, and that's true whether you're solving for dingoes and sheep, or whether you're solving for malicious actors in a software environment or in a software world. You need to be vigilant and you need to keep your security structures in place. So we can click again. We're a little late today, so I'm going to move forward a little bit quickly. I just want to summarize. Security is best handled together. We are a community. We have a community of actors that do a variety of different languages, a variety of different use cases, and a variety of different deployments. We build in different ways. We ship in different ways. We do a lot of things differently around a common code base. Let's discuss the security concerns that we may have with that code base and the way we're using it together. Let's not look the other way. If you look closely at this picture, there are actually two ladies just to the left of the text who are constantly looking forward, and they're the vigilant ones. Everyone else is, keeping their eye on something else. I assume a baseball in this instance. But we can't all just look the other way. We need to be willing to discuss issues where it may feel like we've been negligent. It's not true that we've been negligent. It's just that we constantly need to discuss, we constantly need to maintain, and we constantly need to upkeep around the topic of security, especially in these days when security and open source are a hot topic. They go hand in hand with each other. Malicious actors are starting to pay attention and starting to leverage the opportunities that open source provides to create vulnerabilities in our software. And it may not be Beam, it may be some little project somewhere that is struggling for attention, that is the problem that you happen to pull in as a dependency. So it's very important that we're not only talking with each other, but also talking with other communities about how to make sure that we continue to provide a secure and safe environment for software development. And that is my talk. If you have any questions, I suggest ask really hard questions because Kenneth Lundin has agreed to help me answer them. I'm not an expert on Beam, and it may be that you have a really hard security question to ask. I'd love to see a hard one that stumps Kenneth. But anyway, I'm open for questions. Thank you, Francisco.
So thank you very much, Chris. Really, really interesting. If you could please, put all of the questions in the chat, and I will try to get to them to the best of my ability. Yeah, I found this discussion very, very interesting. I mean, Erlang Solutions has probably for about a decade now provided the binary distros, so the download of the binary packages, and we've got 15, 20,000 downloads per month. And I'm often surprised, when I discover how these binary packages are being used, for this very reason. But again, it's if we look at some of the safety critical things we're actually doing and working on, we're looking at financial switches, stock exchanges. I'm amazed that the vulnerabilities haven't been more vulnerabilities haven't been highlighted. So does anyone have any questions? Please put them in the chat, and Chris and Kenneth will do their best to answer them. I think there's a comment from Fabian, which I think is a very good one, and there's actually a really good talk by Joanna Larsson, who is on the program committee, which is about diffing hex packages, which I think you can actually go in and search on our YouTube channel. I think she gave it at Code-Beam in San Francisco. Yeah, and I'm actually not getting the updates. Martin, you're seeing the questions as well. Go ahead.
Yes, so many browser windows. So there's a question from Michael and Nicolas. Is there already a central source for security related discussion somewhere within the EEF, for example?
I can answer. I mean, there is a security working group in EEF, but I wouldn't say there is an open discussion forum or something like that regarding security. It is, I think it's close to the members of that group, actually, right now at least. But I'm not 100% sure, but I think it's a good idea to have open up something there. I can bring that up if we don't have it.
Yeah, I mean, it's good. It's good, Kenneth, to have a group that handle issues that are raised that isn't in the public eye. It's good to close the issues before they're made completely available to the public.
Yes.
But again, I think it's also good to have a different channel maybe for open communication.
I mean, we also have, a special place where you should report security problems regarding the beam, for example. And that is on purpose, not. You don't send them in the open issue tracker. You send them to our closed group handling security matters first, and then we publish it when we have a solution.
Yeah. There's another question. Are there any known security concerns or areas for improvement with Rebar 3 and Hex?
I can comment. At least for me, the slide Chris showed here and mentioning Rebar 3 and Hex is that you, during the build, are fetching things from GitHub, for example. Of course, you can fetch them from Hex as well. And you are not really sure you are fetching the thing you think you are fetching. And for that reason, for example, at Ericsson, it's becoming strictly forbidden to fetch anything from internet during a build. You must have the open source component in place and thoroughly checked before you can use them in a product.
Yeah,
and you fetch them from the local place inside the company.
Exactly, that is the case with all of our kind of enterprise customers as well, indeed. And there's one question which actually I don't know the answer to myself, which is really interesting. Has there been an issue in the Erlang package ecosystem similar to some of the bigger node package manager issues? and it's someone who's not familiar with the Erlang ecosystem, so you're very curious. I'm not aware of any issues, but
Hello?
Yeah, go ahead, Jose.
Yeah, so so one of the things is that, I'm not in the Hex team, but I've been following their work since ever. So one of the things is that every time there is an issue in JavaScript, right? So I think everybody's like, oh, are we vulnerable to that? So a lot of the times we were not vulnerable to that. So for example, oh, a package was removed and is not security related, but a bunch of systems start failing because the package was removed. You can do that after 15 minutes. So a lot of the vulnerabilities that we see happening elsewhere, we immediately check to see if we are vulnerable or not. And most often we are not vulnerable. We already had mechanisms in place to prevent that. And related to the previous topic about vulnerability on packages, we had the Google Swarm of Code with the Erlang Ecosystem Foundation. And one of the work that was done was to have security vulnerabilities disclosure within Hex itself. So you'll be able to disclosure that in Hex. The Erlang Ecosystem Foundation Security Working Group is going to look at that report, work with the maintainer of the package, and then disclose that to everybody. So we are also improving our processes all the time and try to bring the secure packages and responsible disclosure and everything that is related to that.
Well, thanks, Jose. Yeah, and I just want to reiterate, I wasn't trying to say that there were issues with Hex and Rebar 3. It was more a question of, do you know if you're following best practices when you use them? And are these improvements that Jose just outlined, are they actually being taken advantage of as we do our builds in Erlang? And it's not a question of whether they exist, it's a question of whether we leverage those capabilities. So yeah, I just want to reiterate that I wasn't trying to pick on those two tools. They're just commonly used in the Erlang ecosystem, and it's important that we understand what they're doing.
Yeah, definitely. And we need to reinforce each other, right? Like the community needs to help us improve, and we need to help the community improve as well. And we need to keep the cycle going.